Good morning, everyone. In this session, I'm going to cover Lambda expression, which is introduced as a part of Java 8 feature. The main topics that we are going to cover in this sessions are what is Lambda expression, how we can use Lambda expression, where we can use Lambda expression, and we will also see some of the examples where we will be using Lambda expressions. So let me start with the basic introduction of what is Lambda. So in Java 8, Lambda introduced as a support for functional programming. So as we already know, Java is strictly object-oriented programming, and in today's time, the need is arise to support functional aspects of programming as well. So to introduce that in Java 8, they have introduced Lambda expressions. And lambda expression is nothing but an anonymous function which will not belong to any other class or any object. And a compiler will evaluate the lambda expression using invoke dynamics. Okay, so now we'll basically see what where we can use lambda expression and how we can use lambda expression. So for the question where we can use lambda expressions, so we can use Lambda to create anonymous function or to implement functional interfaces, and by both we mean that whenever you want to do a declarative coding, we will be using Lambda expressions. And to support this Lambda feature in Java 8, they have also introduced some other libraries like Stream, and in collection they have introduced consumer interface as well. So we'll see how it is working. Before that, we will see how we can use lambda. I mean, what we need to do to use lambda expression in our coding. So the basic syntax for lambda is there will be a round parenthesis in which we will pass arguments. Then there will be an arrow, and there will be an expression that needs to be evaluated. Now there can be different flavors for this lambda expression. There can be a single parameter, or there can be zero parameter, or there can be more than one parameter in the lambda expression. I mean, input parameters can be there. So in case of single parameters, what advantage we are having is if we want, we can avoid the round parenthesis that is given. So we can write it as like simply argument, arrow, and whatever the expression we want to evaluate. But in case of zero parameter and more than one parameter, I mean two or more parameters, what we are supposed to do is these parentheses are mandatory. We cannot ignore them. Even we can also return values from our lambda expression, because at the end it's an anonymous function. So if we are evaluating something and manipulating something, we want to return the values. So we can use a return statement as well. And there is one more way by which we can use by which we can also return values. For example, I have binary values, so I can write like this. If I'm having two parameters and I want to return if E is greater than B or not. So what this function will do, if I'm passing here 4 and 5, and the values here it should be, I mean for this it will return whether it's true or false based on the value that is being passed in this function. Okay. And even if our implementation is having more than one line of code, so we can use the curly braces as well, but it's not advisable, because the main advantage of having lambda is it will increase our code maintainability and readability. Now if we introduce lots of code over here, then the advantage that we are going to have, we will lost it. One more thing what we can do is we can, for this function as well, I can write it like this, and here I will call do my work. And here what I'm doing is I'm passing the variable a as well. So here now I will define one more method, do my work, which will be taking this whatever value it is having, and here I will write my code. My logic will resides here. Now if we see, so this will be the nice representation of lambda, because from by seeing this I know, okay, I want to manipulate something on this variable a, and for that I am calling this method to my work, and all the logic, main logic that will be the complex logic will reside in this particular method. Okay, so now we will quickly go through some of the examples of where we can use lambda and how we can be using it. Okay, so for that I will first start with a simple example of creating a normal thread which will print running in the new thread into the console. Now to do that, if I follow the traditional way, so what I'm doing is I'm creating a variable of thread, then calling the thread constructor, and in thread constructor I'm supposed to pass a runnable object. So for runnable I will be creating new runnable anonymous class, and in which I will be overriding the run method, and over there I am going to write system.out.println. Now if we see this, to simply print this statement, what I'm doing is I'm wrapping it into some anonymous, wrapping it into a function, and wrapping that function to some anonymous class as well, to just write a single line of code. And here also if I do this and if I run it, let's see how it goes. Okay, so it is printing running in main thread, and comment this as well. So now if I run, it is a printing running in a new thread and main thread method. Now if I want to create the same thread using lambda expression, so here what we are doing is, for thread expression, creating a thread, we want to implement a functional interface that is new runnable, which is having only one method called run. So any interface which is having single method to implement are called functional interface. Now runnable is one of the functional interface, so we can use lambda to implement the runnable. So what we can do is we can simply write like this, and alright, yeah, I'm done. Now if I run same, what it is doing, running in main thread, running in new thread created by lambda. Because we have changed the assigned the th to this new created instance. Now if we see, this one line of code contains the same amount of logic that was written over here. So this is how it is. And one more advantage that if we want to see, we can see, like if I'm creating a single anonymous class, let's take an example. In this case, we comment this. Okay, so whenever Java compiles this code, it will be having an anonymous class created for the new runnable interface that we have implemented. Now in case of lambda, Now, for example, I am commenting this and create a thread like this. And if I come here and check the directory, no single class is created. So the advantage here of running using Lambda instead of anonymous class is, now take an example where I'm supposed to create so many objects of thread. Let's first take an example of this. I'm creating 6 to 7 thread. Okay. Now if I check here, for each anonymous class implementation, it will create one class file. Now what it will do, for if for me it is the case that I'm going to create thousands of thread objects, then what it's going to do is create thousands of class file, which will increase my memory, and it will increase my jar file. And if the jar size increases, it will increase my load time of the jar, and at the end it is going to affect my performance, my application performance. So it's always better, in case, now the same case, if I remove this and I create 6 instance of thread, I see no other class has been created, because this creation of implementation of functional interfaces are taken care by invoke dynamics. So it is not going to create any new classes. So this is how it helps in case of functional interfaces, where we normally used to create anonymous classes, but instead of that, now we can use this. Now let's create one more example that I'm having list of integers and I want to print them. I want to print all of them. So how I'm going to do that? So for doing this, here what I've done is I've used the for each iterator, and for each elements I'm printing that value. Now what I can do in case of lambda. So here I will create a lambda expression, which okay, here I will create lambda expression which will do the same. But yeah, I don't want to mention the data type, because it will take from this generates value that, oh, it's an integer, so this function will know the whatever t will come, it will going to be an integer, and I want to print that value. So in numbers collection, I have this for each iterator which have consumer implemented. Now to consumer, by this consumer is going to have an accept method, and in this accept method I'm going to print that integer value. T. The same thing what I'm doing here can be done here as well. Now if I run the same, it is going to print the 1 to 10 two times. Now this code is taking so much of space, and the logic behind it, I can accommodate the same thing here within the very short span. This was a very simple case. Now think of the complex case where I want to print sum of double of all the even numbers, and I don't want to print this, so I will comment it as of now. So here the sum is 16. What I'm doing is I'm iterating through the for, using for loop, and I'm checking is the number is divisible by 2. If it is, then just add it the double of the value to the sum, and at the end of it just print the sum. Now the same thing if I want to achieve in my Lambda expressions, I can use the stream class. So how I'm going to do that? So I will put numbers dot stream. Now in stream, what first thing I want to do is filter. Now filter all the numbers which is divisible by 2, 0. Now once I get that number, what I want to do? Once I get that number, I want to map it to an integer. Okay. Because I want to manipulate it, I will say multiply it with 2. Now once I've done that, what I want to do, I want to sum them up. So yeah, I'm done. Let's do the same thing. So let's print this value. And right. So okay, so it's there. So what I'm doing is for these numbers, I'm creating a stream to process that. And then I have filtered all the elements which is divisible by 2. Then I double that element and yeah, just sum it up. That's it. I'm done with my values. Now let me take one more example of an interface implementation. Now let's take an example that I'm having an interface which is my comparator, and I'm going to compare my values using that. I have one method which needs to be implemented to compare the values. And what I can do is, for example, if this particular comparator I'm going to use at multiple in my method or in my class. So what I can do is I can create an object for my lambda. So the normal case will be like this. The implementation I'm doing, and it will have whenever I want to use, I can use it as an object. I can use it as an object. So now what if I want to use a lambda expression instead of this? What I can do is I can remove all this. I can just say pass a and b and return a is greater than b. So I'm done. If I run this, it will say okay, it's not returning the value. So these are the basic examples of lambda expression that I have covered today. And yeah, feel free to visit my blog Code Pumpkin. Happy learning. Thank you.